Welcome to another Explainer. Today, we're diving into a massive structural upgrade and how science itself is actually done. If you're fascinated by the cutting edge of research, artificial intelligence, and automation, well, you're in exactly the right place. We are going to break down the architecture of collaborative self-driving laboratories. We'll explore how they work, why they absolutely matter, and the hurdles we've got to overcome to unlock their full potential. Let's jump right in. Okay, let's dive into this. How do we solve the world's most complex problems faster? It's arguably the defining question of our time. Whether we're talking about developing advanced sustainable materials for clean energy or, say, life-saving pharmaceuticals to combat novel diseases, the stakes are massive. And honestly, the clock is ticking. The problems we're facing on a global scale are evolving at just breakneck speeds, and that means our methods for finding solutions, they need to evolve just as fast. But right now, we're facing a really severe research bottleneck. The modern global challenges we just talked about, they demand entirely new, innovative approaches to experimental planning and execution. Because think about it, the traditional way of doing science, manually mixing chemicals, testing one specific variable at a time, spending weeks analyzing results, and then starting all over again, it's just incredibly slow. Our contemporary problems have completely outgrown those traditional manual methods. It creates this massive backlog in scientific progress. So we need a total ground-up overhaul of the experimental process. And that bottleneck is exactly what self-driving laboratories aim to solve. Now, this isn't just an incremental step forward, it's a paradigm shift. It's kind of like the evolution from manual assembly lines to fully automated smart factories, but instead of building cars, we're building fundamental scientific discoveries. It's a major technological leap that literally changes the speed limit of human knowledge. It allows us to test and verify hypotheses at a scale that was, frankly, completely impossible before. So what exactly are they? Self-driving laboratories, or SDLs, are advanced systems that automate experimental tasks in chemical and material sciences. But actually, look at the second half of that definition because it's absolutely crucial. They also automate the design and selection of experiments. This means they aren't just robotic arms blindly doing what a human programmer tells them to do. No, they're automating the actual cognitive decision-making processes of science. The machine runs an experiment, analyzes the real-time data, and then independently decides what experiment it should run next to get closer to the desired result. Mind-blowing, right? The whole process works as a continuous cycle. In step 1, the system designs and selects the experiments, basically forming a hypothesis on the best path forward based on existing data. Then, in step 2, it automates the physical execution, perfectly measuring, mixing, heating, and testing the materials, totally without human intervention. And finally, step 3, it feeds all of that fresh data right back into a loop to optimize the entire research process. It learns, it adjusts, and it immediately starts the next cycle. And it does this 24 hours a day, 7 days a week with extreme precision. Now, what's really interesting about this is that the immediate benefits of these self-driving labs go way beyond just raw speed, although, radically accelerating discovery is certainly the most thrilling headline. But by optimizing research processes with algorithmic precision, SDLs significantly reduce material usage. They just don't make the same physical trial and error mistakes that human hands might make. So that means less chemical waste, vastly lower financial costs, and much more sustainable research practices right out of the gate. However, every major leap forward comes with a catch, right? For self-driving laboratories, it's the accessibility challenge. You can really think of this as the kryptonite of SDLs, because despite their incredible power and their proven potential to completely reshape chemistry and material science, these advanced systems currently face a major structural hurdles. We aren't just talking about a slight technical glitch here. This is a systemic barrier that's actively holding back the pace of global innovation. Let's break down this bottleneck a bit more. First off, there are really steep technical challenges in actually deploying these systems. Building an SDL requires a rare, highly specialized blend of robotics, artificial intelligence, chemistry, and software engineering. It's tough. And because it's so hard to build them, we're currently seeing very isolated, siloed research efforts. Basically, only a few top-tier, super well-funded institutions have them. And that leads directly to our third point, extremely limited access for the broader scientific community. If these incredibly powerful labs just remain locked away in a few isolated academic basements, well, their world-changing potential is totally wasted. But there's good news. The authors of this research provide a brilliant blueprint for the future. The ultimate answer isn't just building better, faster standalone robots. No, it's connecting the labs and building a global network. To truly revolutionize science, we have to fundamentally change how these self-driving systems interact, not just with the scientists operating them, but with each other. We need them sharing data and hypotheses across the globe in real time. And this brilliantly illustrates how we can actually shatter that accessibility barrier. The authors propose two complementary solutions. On one hand, Solution 1 focuses on creating centralized self-driving user facilities. Think of these almost like massive high-tech hubs or supercomputers, where researchers from anywhere can just send their experimental parameters remotely to be run. Then, Solution 2 takes a more decentralized approach, creating distributed networks of self-driving labs. This means linking up smaller, specialized SDLs around the world into one massive, collaborative hive mind. Both of these frameworks are going to be absolutely essential for expanding global access. Networking these labs essentially transforms two vital types of collaboration. First, human-machine collaboration. By connecting these systems, we heavily enhance the automated design, execution, and optimization across the board. The AI gets fundamentally smarter because it's learning from a much wider array of connected experiments, analyzing failures and successes from across the entire network. But equally important is the second aspect, human-human collaboration. By democratizing access to these powerful tools, we foster a vastly more inclusive research community. We literally break down the geographical and financial barriers that previously kept brilliant scientific minds separated. Because of all this, we are truly standing at the precipice of a brand new era of science. By fixing that accessibility bottleneck and bringing these labs online in a collaborative global network, the ultimate impact is profound. We can begin facilitating previously untenable research projects. We're talking about problems that were historically way too big, too complex, or that would literally take 1,000 human lifetimes to test through manual trial and error. They can now be tackled efficiently. Imagine discovering durable materials for zero-emission energy grids, or developing entirely new classes of synthetic medicine that we just didn't have the capacity to explore before. So the crucial point here is beautifully summarized in this direct quote from the source material. It says, "Collaborative self-driving research is crucial to research acceleration amidst ever more complex problems." I mean, that hits the nail on the head. This isn't just a luxury. It's not some nice-to-have upgrade for a few elite universities. It's an absolute necessity if we're going to keep pace with the complex global challenges threatening our world today. The scientific community has got to ensure that these brilliant, self-driving labs learn to talk to each other. Which brings us to a really fascinating final thought for this explainer. With labs driving themselves and sharing data across a massive global network, what previously untenable discoveries will we make next? Seriously, when boundless human ingenuity is finally paired with tireless, networked, artificially intelligent laboratories, the historic speed limits of scientific discovery, they just disappear entirely. Thank you so much for joining me for this deep dive into the architecture of collaborative, self-driving laboratories. Keep questioning, keep learning, and I'll see you in the next explainer.